Okay, so in doing this problem, like before, we need to make sure we take what's inside the absolute value and set it equal to 0. So 2x plus 6 equals 0. Now we'll subtract 6 from each side. So 2x equals negative 6.
Divide by 2.
So x equals negative 3. So that goes in the middle row of our table. Now, there are 7 places here in this table, 7 rows. We don't really need 7 rows. We really only need 3 rows. We need to graph 3 points, technically. That is the vertex, and then one above and one below the vertex. But we're going to go ahead and do all 7 here. So to get the values of x above negative 3 on this chart, you're actually going to subtract 1 each time. So negative 4, negative 5, negative 6. And then below it, you would add 1 each time. So negative 2, negative 1, and 0. Next, we would take these values, plug them into the chart, or to the function, to get our y values. So 2 times negative 6 is negative 12, plus 6 is negative 6, and the absolute value of negative 6 is positive 6. And then negative 5 times 2 is negative 10, plus 6 is negative 4. Absolute value of negative 4 is 4. Look at the pattern that's developing here. 6, 4, 2, yep, 0, and then what? Nope, 2, 4, 6. It goes back up, because if it doesn't, it's not going to be absolute value. Both sides go up with the same y values. Alright, so now we can graph this. Negative 6, 6, negative 5, 4, 4, 2, 3, 0, and then you're just reflecting these points. Now, once you have those points graphed, of course you can draw. I put it in the wrong spot. It should be right here. Put a straight point on there if you didn't notice that already. Alright, so there it is. This is nothing. Alright, now, domain. Same as before, guys. Negative infinity to infinity. The range happens to be the same as before. It's not always going to be the same, but for this time it is. 0 to infinity. Alright, now I want to do another one of these on the video, so you'll have 2 examples. So let's flip the page. Okay, so number 3, we are going to do number 3. Notice that we've got an absolute value of x plus 5. This plus 5 is going to cause this graph to shift up 5 units. Wherever the graph would normally be, well, it's going to be up 5 from where it would normally be. Kind of your y-intercept changes, yes. Alright, now, my absolute value function is absolute value of x. So that x equals 0. Alright? You take what's inside the absolute value, set it equal to 0, so x equals 0, and that's my vertex x value. Now, like we've done before, we're going to subtract 1 to go up, add 1 to go down, so minus 1, minus 2, minus 3, 1, 2, 3. And then we plug into the function. So absolute value of negative 3 is 3, plus 5 is 8. Negative 2 plus 5, absolute value of negative 2 plus 5 will be 7, 6. Alright, 5, and then start over. 6, 7, 8. Okay, so it goes back up to 8. Now again, technically all we need are these 3 points. But if you want to do more, you can. When we graph this, negative left 3, up 8, negative 2, 7, negative 1, 6, 0, 5, 1, 6, 2, 7, 3, 8. Got my V. Notice that it has been shifted up 5 units from where it would normally be. as the parent function, the vertex would be at 0, 0, but since we went up 5, we shifted it up 5 plus 5, it went up 5. Alright, so like always, what is our domain? Yep. And what is our range in this problem? Bracket 5 to infinity. Okay, let's look at number 5. This will be the last one on video. Okay, so for number 5, again, we want to, this is a little different because we have this minus out front, this negative. That's going to cause a reflection. This graph is going to face down instead of facing up. Now, having known the rule, we're going to do x plus 1 equals 0, so x equals negative 1. So that is the x value of our vertex. Now we can subtract 1 moving up and add 1 moving down. And then plug these values in. So the absolute value of negative 4 plus 1 is the absolute value of negative 3, which is 3. But that negative out front makes it negative 3. Okay? And so we're actually going to go up by 1 right here. Negative 2, negative 1, 0, and then what does it do? Starts over, going back up, right? It has to, it's not absolute value. Okay, now we graph it. Negative 4, negative 3, negative 3, negative 2, negative 2, negative 1, negative 1, 0, 0, negative 1, 1, negative 2, 2, negative 3. It's facing down. So my domain is still the same. My range, this time is a little different because the lowest value is negative infinity. And it goes up to what? Infinity? It goes up to as high as what value? 0. So it's kind of swapped this time. Instead of 0 to infinity, it's negative infinity to 0. Alright, I'm going to stop the video there. Okay, so number 7 is the last one on video for the absolute value functions. Alright, so we put our dotted line at 4. Now we're going to graph this first equation, which is negative 2x plus 1. So let's go up 1. That's our y-intercept. And then negative 2 is our slope, so down 2, right 1. And then graph that line all the way to the dotted line. Okay, so we want the part of this line from the dotted line to the left. Now, is it going to be an open or closed circle on this dotted line? Open, good. Okay, so we're done with the first one. Now the second one. Absolute value. Now, we only want the part of this function to the right of this graph, correct? To the right of this dotted line. But it's going to be kind of hard to figure out where that is without just drawing or graphing the entire thing. So we really need to have an idea of what this is going to look like, so we probably need to do a table. We only need to do 3 values, but it's going to be important for us to have those values where we can see them. Alright, so the first thing we're going to find is the x value of that vertex. So we're going to do x minus 3 equals 0, so x equals 3. Well, that goes in the middle. So to go up, I subtract 1. To go down, I add 1. And now we plug those values in. So 2 minus 3 is?
2 minus 3 is negative 1.
Negative 1. And then 3 minus 3 is?
0.
And then 4 minus 3 is?
1.
1. We had negative 1, but what should it really be?
1.
It should be positive 1, because the absolute value of negative 1 is 1. Alright. Now, when we graph this, graph it just like normal. So, to the right 2, up 1, to the right 3, 0, to the right 4, up 1. Now, is that going to be open or closed based on that symbol? Greater than or equal to, what is that? Closed. Right here. And remember, we only want the part of the graph that is to the right of this thing. So, I'm going to, just from that point, get my line situated and graph just the part to the right and erase the other points. So there it is. Alright, now there is a little bit faster way to do this when it comes to the absolute value. And it has to do with using the domain value that we're given. What is the only domain value that we would need for this graph? 4 or greater, right? So technically, I could start at 4. But that's only for these piecewise functions. I technically could just start at 4. 4 minus 3 is what? 1. And then do 5. 5 minus 3 is 2. So I'd have a point here and a point here, and just draw it. I'll be done. But I hesitate to do that because that I don't know, that it kind of throws people off, I think. It would throw people off. If you just graph the whole thing and erase the part you don't need, it's more work, but you can kind of see it a little bit better. Alright, I'm going to stop there with the video.